So my name's Merlin Crossley. I'm the Deputy Vice-Chancellor Academic Quality here at UNSW. And it's an absolute privilege to be involved with the Scientia Education Academy. So for a long time, we've, at an individual level, prided ourselves on, people doing inspiring teaching that has changed lives, and people have also recognized inspiring research. And the research is often visible, and the researchers often work on very specialist things and have to travel the globe to exotic locations to gather with other researchers that understand their research. But in teaching, we have a lot in common across the university, and everyone's doing that, and people are having their own experience. But we wanted to have a group of people with the most experience and our most respected people in teaching and learning and education generally, to get them together to share their wisdom and give leadership to guide and improve teaching and learning at UNSW. So we formed the Scientia Education Academy, which is built up of the most respected teachers, about 50 of the most respected teachers. And they're like a group of elders. And on that note, as I welcome you all here today, I want to acknowledge where we are welcoming you to. So we're welcoming you to a computer screen, but my computer screen is on the land of the Bedegal people. And I acknowledge that the university, the Kensington campus, is built on the land of the Bedegal people. Our campus in the city, the Arts and Design one, that's on Gadigal land. And we've got one on Ngunnawal land in Canberra, if you're from UNSW Canberra. And you may be in other places. And, so I've been taught not to do the tokenistic acknowledgements of country by some of my Indigenous colleagues, but they say, do talk about Australia's history, where you are. And I've asked my colleagues, what are elders? And they've told me that elders isn't based on age, it's based on people who emerge as leaders and are respected by others as leaders. We're always giving leadership training here at UNSW, but I think that it's best sometimes when leaders emerge, and I feel that the members of the Scientia Education Academy have emerged as our elders in teaching, even though some of them are so youthful. Now, I don't pretend it's the same as Indigenous elders. I'm not qualified to comment on that, but I do feel that they are the sort of the respected leaders. And we have these groups of seminars because we want that leadership to help inform us all about things that are working and things that are interesting in education. So today we have two speakers, and Patsy will introduce them. Professor Anne Gardner from UTS, and it's absolutely a pleasure. We love it when people come from other universities and we can welcome them, and we do learn from each other across the sector so much. So Anne's Associate Dean and in the Faculty of Engineering at UTS. I have to say, we've learned a lot from UTS. We've got some great staff from UTS, and so it's an absolute pleasure to have you here, Anne, but I'll let Patsy introduce you. And then one of my colleagues, Jayashri Ravi Shankar, who's definitely a very well-respected education here and a member of the Scientia Education Academy, and she's from our Faculty of Engineering. So it'll all be about engineering today, which is so often about engineering at UNSW. So I think my other jobs are to tell you that we're recording. If you don't want to be recorded, just hide. Turn your camera off and don't say anything, and then, in effect, you won't have been recorded. The other thing I want to say, I do want to introduce that I'm going to hand over to Patsy Polly, but I also want to say that I'm going to ask, if he manages to join successfully, Professor Alex Steele, our Pro-Vice-Chancellor Education. And Alex has been, he's been Pro-Vice-Chancellor Education and Student Experience and had a huge impact. He's also been a director of the Scientia Education Academy, and I'm going to ask him to give the vote of thanks, provided his Zoom link works. I'm only saying that because mine didn't work and I had to do some of my masterful troubleshooting, but hopefully everyone's on board now, but I'm sort of stalling just in case people aren't. So he'll give a vote of thanks at the end, if possible. And now I want to hand over to Patsy Polly. So Professor Patsy Polly is another member of the Scientia Education Academy, but she's not just a member of it, she's the director. So she's the leader of the first among equals, we could say, Patsy. And it's great to have you here. Thanks for all your work for UNSW and your leadership. And I'll go on to mute now and let you introduce the speakers and do question times as well. Over to you, Patsy. Thank you, everyone.
Thank you so much for those kind words, Merlin. And it really is my pleasure to be introducing our two speakers today on behalf of the Scientia Education Academy at UNSW. So today in the room, we are so fortunate to have Professor Anne Gardner from UTS and Associate Professor Jayashri Ravishankar from our very own UNSW. So just to introduce you to the concept today of the way we're going to present, we have two speakers, so 20-minute presentation followed by a 5-minute question time for Anne, and then we'll start a 20-minute presentation from Jayashri, followed by a 5-minute discussion or question time from Jayashri. So without further delay, Professor Anne Gardner is the Associate Dean Teaching and Learning at the University of Technology, Sydney, Faculty of Engineering and IT, and the Executive Committee member of IFEES. And I looked that up, and it's the International Federation of Engineering Education Societies.
Yeah,
so,
certainly is.
Fantastic. So Anne's primary field of research has been engineering education for the last 15 years. So I would say a very a leader in the field, you know, one person who's probably led from the very beginning. She's the immediate past president of the Australasian Association of Engineering Education, AAEE, and has been awarded the AAEE Research Design Award twice. Congratulations, Anne. She also facilitates the AAEE Annual Winter School, which supports engineering academics to learn about engineering education research. Now, Jayashri. Jayashri is the Associate Dean Education at UNSW Faculty of Engineering. Jayashri is a Scientia Education Fellow and an education-focused academic at UNSW Sydney. Her teaching and research interests include power system studies, renewable energy integration, and engineering education. She leads best practice advanced teaching in electrical engineering through imaginative initiatives and industry partnerships, including blended industry lectures, teamwork, and flip mode strategies. Esteem indicators include a Senior Fellowship of the Higher Education Academy awarded by Advance HE UK, the UNSW Teaching Excellence Awards, and the Australian Award for University Teaching Citation. Congratulations, Jayashri. So without further delay, I'm now handing over to Anne to get us started. Over to you, Anne, and thank you so much for joining us today. It's our pleasure to have you.
Well, thank you very much for welcoming me and allowing me to talk to you today as well. I'll just make sure that you can see my slides. Yep, okay, thank you. So today I'm talking about research design in engineering education. And like all fields, if we want to see innovation in teaching practices, in educational programs, then a lot of that innovation will come from research. So that's why we engage in scholarship of teaching and learning and educational research as well. So engineers, with our stereotypical technical research, engage in a research paradigm that is slightly different to what's required in the educational field. And one particular difference is the need to actually describe a particular methodology or theory or a conceptual framework. Now, colleagues from social sciences, this will be second nature to them. But for engineers, it's quite a different way of operating. There are other differences as well around increasing expectations that researchers will describe their positionality, recommendations for education practice, having research questions rather than a hypothesis, and of course, different data collection methods. Another difference is that in engineering education research, we tend to write in first person rather than the third person. So we're acknowledging that way that a person is actually doing the research rather than trying to pretend that it happened without a person being involved. So in this presentation, I'm going to look at a couple of different frameworks, and we'll see how many I can get through, with some examples of where they have been used in the education, the engineering education context. So in my role in A Squared E Squared, I have been facilitating the winter school that the association runs. And this is a week-long research school. So as part of that, I've noticed, or it's a common experience for engineering researchers to not be aware that they're actually researching in a positivist frame of reference, where there is an idea that there is an objective reality, and my goal is to do the best I can to measure that, to discover the truth. The truth is out there if we've got really good measurement techniques to find it. Now, because everybody else in engineering is doing similar research in a similar sort of perspective, then it's a bit like this fish in water. You don't realize that there is another way of working, which is typical for people doing work in the education space, including the discipline-based education space. So if we take an interpretivist perspective, then we would be saying that objectivity is really virtually impossible, and that reality is co-created between the people involved in whatever the activity is. So when we're working in an education space, the research subjects are sentient beings, although for some of our students that might be a little bit questionable some of the time. We have little control over the variables, and this sort of research, the fact that there is a different research paradigm, is a bit of a threshold concept for some engineers. So when they come along to research school, to the winter school, to learn about a different sort of research, there's often resistance to researching in a different way. So, but it's only really by experiencing that difference that you realize there are different ways of researching. And so a lot of our participants feel like they are a fish out of water, but by the end of the winter school, most of them have actually adapted and evolved to breathing air as well as water. So if we look at some of the review criteria for one of the top ranked engineering education journals, you'll see that they specifically ask for conceptual or theoretical frameworks or historical contexts, and the manuscript has to have a well-developed and clearly articulated appropriate methods and research approach. So we're trying to encourage all of our engineering education researchers to certainly articulate this theoretical framework clearly. It's part of the journey of becoming a different sort of researcher. So one of the frameworks, for example, that you're probably used to is Bloom's taxonomy. And this is a way of thinking about different types of cognitive activity. And academics use this to frame their thinking about learning and teaching activities. So in a similar way, we use theoretical frameworks to frame our thinking about our research. So I'm a civil engineer, and so when I think of a frame, I typically think of a frame in a building. And the frame in a building, what that does is it separates what's outside the building and what's inside the building. And it also provides linkages between different elements of the structure. And that's a similar sort of thing to a theoretical framework. So the elements of the framework will tell you what's included in that particular theory, what's not included. And it will also tell you how the different elements of the theory relate to each other. So one theory that we've seen used in engineering education is self-determination theory. So it's one of a number of different motivation theories. This one, the classics, or the main people I suggest that you look at if you're interested in this theory are Deci and Ryan. And this is the first theory that shows what we call the power of three. So there's three particular elements to this theory. So these three psychological needs are competence. So that's the feeling that if I'm not already competent, that I can develop that competence. So I'm confident I can develop the competence. Autonomy is around choices. What choices, what control do I have? And the last one is around the social or relatedness. So that's a need to actually connect to other people. So colleagues have used this both in their research, but also in their teaching. So they've used this theory to scaffold design of assessment tasks with their students. So that again provides some support or a foundation for developing competence of the students. If they can understand what it is that's behind the design of a particular assessment task, it actually provides a bit more of a hook for them to be involved in participating in whatever that is. So there's a few different theories that have three aspects to them. So that's one of the magic numbers. So if we reduce a student's feeling of competence, then there's a bit more resistance to participating or continuing to engage with that particular activity. So this paper I've quoted down the bottom here, applying the self-determination theory to explain student engagement in online learning, is actually in the school space. So it's in the K-12 space, but they have completed an interesting study to look at what was going on during COVID when everybody was teaching online. So the self-determination theory was developed in a face-to-face teaching context. So these, in this paper, the researcher has extended the application of the theory to include a technology context. There are other motivation theories, but this is one that feels quite accessible for in a lot of engineers. Another bunch or category of theories is around practice. So here I'm talking about practice theory, which is mainly based on or comes from the work of Shatsky. And this one doesn't have 3 elements. We've got the 5 this time. That practices are embodied. So you actually do it, physically do it. There are actions involved. It's materially mediated. We do it with things. So the practice of attending online presentations is mediated by our computer screens and by the software involved. Practices are relational. We tend to do them with other people. They're situated in a particular context. So the context of this presentation is that we are in universities in Sydney, and we're all interested in teaching and learning and the scholarship that supports that. And they are emergent. Each time you do a practice, because it's situated, because it's contextual, there are likely to be changes. So all of those 5 things need to be present. And there can be variations in how present they are, or the relevant for a particular context. So I was involved in a project where we interviewed construction engineers, and we were trying to find out what are the practices around being a site engineer in a construction company. One of the first practices that we identified through focus groups and an observation was this one of the site walk. So every time you do a site walk, it's different because there's been progress, hopefully, on the construction project. There can be different people involved in the site walk depending on what the issue is that's being resolved. It's done with your body. You actually walk over the site, and you do it with materials. So it might be a Sharpie writing on the screen of a Jeep if you're driving over a site, or you certainly need to have your personal protective equipment, so hard hats. There might be tablets with drawings or site plans. So all of those elements of practice were evident when we were looking at the site walk. So that was a useful theory to apply in that situation. Another practice theory that sort of developed from or evolved from practice theory is this one, practice architectures theory. And one of the main people behind this is Stephen Kemmis previously from Charles Sturt University in Wagga. And again, we're back to the power of 3 again. With our practice architectures, we've got the sayings. What do people say to each other? So he calls these the cultural discursive arrangements. I tend to use the more accessible language, or more accessible for a lot of engineers anyway. So the sayings, what people say to each other, the doings of a practice, that is the physical things that you do, but also what you do it with, and the socio-political arrangements or the relatings. And this last one brings in aspects of power and hierarchy and how that can influence a practice. So this particular theory, practice architectures, has been used looking at writing practices in engineering. And Rosalie Goldsmith was the main author there. And when she went into what's deemed to be important in engineering practice, or certainly by engineering educators. And in engineering programs, writing tends to be not regarded as real engineering, as important, and not my job as an engineering academic. If I'm the unit coordinator, then it's not my job to be teaching writing. So that was the perspective that she found in a lot of engineering programs. She also led another project, which was looking at the journey of engineering academics to becoming engineering education researchers. And this was actually a mix of different practice theories, but it included practice architectures theory, also a community of practice perspective. And the last one was Bourdieu's theory of practice. So using three allowed us to really triangulate on what the important themes were in that particular project. So you don't have to always use just one. You can combine theories if it's sensible and relevant for the research questions that you're trying to answer and the context that you're working in. You can see these are all in engineering education journals. Just to plug that the Australasian Journal of Engineering Education is now a Q1 journal. So again, we've got three aspects to this theory, which is Bourdieu's theory of practice. This one is a bit more of a heavy sort of theory to get your teeth into. It's probably not a great choice if you haven't used any theories before, but if you're up for it, it does cover a lot of different contexts. So the three aspects of this theory, or elements to be aware of, are around habitus. And habitus has the word habit in it, and that's sort of what it relates to. What are the habitual actions that we take? So that might be anything from every morning when I come to campus, I get my large skim cappuccino in a particular cafe before I come up in the lift to my office. And having coffee is a socially acceptable beverage at that time of the morning, as opposed to later in the evening. An important term for this theory is around capital. Now, we normally associate that with financial capital or economic capital, but in this theory, it's expanded to be social, cultural, and symbolic capital. So in an academic context, a H index reflects a certain status and and a particular capital. I think what we are both of our institutions are trying to do is change the view of what is regarded as capital in academia to include impact in teaching and learning, not just impact in research. And then the field is the, as it says there, the network or the set of relationships. So our field that we're working in is higher education in Australia. Now, different people within that field have different amounts of capital, depending on the work that they have done. So we had some previous participants of our A²E² research school actually use this theory of practice, Bourdieu's theory of practice, to describe their trajectory or their pathway from being a technical engineering researcher to being an engineering education researcher. You can see some of the outcomes there, that universities highly value research output, that transitioning or switching researchers have to develop capital in new sorts of networks, opportunities, and skills, and a change in epistemological beliefs. So that sort of change doesn't happen overnight. It is an ongoing understanding of different ways of doing research. There's another paper quoted there using this theory as well. This is in material science and engineering. So as an emerging field, engineering education research is trying to incorporate different sorts of theories, theories borrowed from education research, but also from the social sciences, to expand the range of tools that we've got available to investigate different research questions. There's another group of theories around identity. So this one, the identity trajectory one, it was specifically developed around academic identity development. And you can see in the figure here, there's a time element to this. So which recognizes that our identities change over time. And it points to 3 different sorts of strands. So the institutional strand is the work that you do on committees, the work that you do associated with particular roles. So as Associate Dean Teaching and Learning, that has a particular institutional profile associated with it, which would be different to the institutional profile usually attached to, for example, level A academic. But you might start as a level A and end up as Associate Dean. There's another strand around networking, and there's 2 elements to the networking. One is the network of authors that you read. So they're the people the authors that you typically go to. But there's also a personal network who are the people that you know. So one of the reasons for going to a conference, for example, is to change your network of authors that you're reading into your personal network by meeting those authors. And there's also this intellectual strand, which is the papers that you write, but also the reports that you write associated with the work that you do at the university, your subject outlines that you write, your assessment tasks, but any other document that you write as part of your work as an academic. So this one we published in Studies in Higher Education. There's a few different identity-related theories around, but that one I found useful looking at academics. One of my other favorite ones is variation theory. which basically says a bit like the fish in water and the fish out of water, you don't really appreciate a range of aspects of the work that you're doing until you see some slight variation. Now, this one is very useful for academics in planning progressive learning activities. So if I'm teaching mechanics, for example, I might change the length of span of the beam. I might change the type of load that's applied. I might change the support conditions so that students can see what happens when changes are made, when there's variation. Now, this theory is particularly linked to phenomenography, which is another perspective or research approach that's specifically or typically used when you're trying to understand experience. So again, this is about investigating different people's experiences and categorizing them into, well, different types of experience. So they will be qualitatively different experiences. And the paper that I'd point you to there is was written by one of my colleagues at UTS, and he studied the different ways that academics conceptualize their lecture. It's quite an interesting paper. Not that I'm encouraging anyone to do any more lecturing than what they absolutely have to, but it is interesting to see the different ways that that people think about that activity that we label a lecture. So that's been a very quick run through of a few different types of theories that are currently being used in engineering education and research in that space, both for research itself, but also to help people frame what they're doing in their teaching. And they can also be used to explain or scaffold those activities with students. And to finish, this is a bit of an ad to come and participate in the A²E² winter school. So the winter schools are usually held somewhere in mainland Australia, and the summer schools are typically held somewhere in New Zealand. So these winter schools are for PhD students, but also for academics who want to learn about a different type of research. So we've had engineering academics, but also academics from science faculties as well, because they tend to have typical similar sorts of challenges to engineering contexts. And on that note, I'm happy to take any questions.
Thank you, Anne. That was great. Good summary of all the things we need to know and how to put them into practice when we start. I can't see any questions coming into the chat, but I've got one. So here it comes, right? When we start doing some educational research or SOTL in our classrooms, we often, as you mentioned, take from the theories presented in the social sciences. So could there be an opportunity with time for us to hybridize a theory from the social sciences and one that becomes more engineering-like? For example, you talked about identity, just so that our tribe, our own engineers, our scientists start to become more comfortable with that type of research. What would you think about that?
Oh, look, absolutely. And not all the methods that are used in engineering are necessarily useless in educational research. So I've talked about a lot of, or framed this presentation around doing qualitative research, but there are a lot of researchers in this space still doing quantitative research. So all the statistical analysis methods are still relevant if someone's doing quantitative research on an educational activity or program. The other thing is that I think engineers are looking for outcomes that can be applicable. They're looking for something that they can use. So another feature, I think, of engineering education research is that it does include recommendations for practitioners. How can I use this in the classroom, or how can I use this in the design of my program? Which is not necessarily always a feature of social science research or straight education research.
That's very true. I started to write in recommendations in the papers that I was writing as part of my education profile, and I thought, oh, is this appropriate? And then people found it very useful. So I guess it is. So any questions from the audience? You can either pop your hand up or turn your mics on, ask a question, put something in the chat. Probably got another minute of potential question time here. Can't see anything in the chat.
So Siva, hi Siva.
Perfect. Okay, I'll read it out. From your experience facilitating the winter schools, what do engineering educators struggle with commonly in terms of qualitative research, or what should they be mindful of when planning their research investigation?
Okay, I think one of the major challenges for engineers researching in this space is, especially if they're looking at qualitative research, is to appreciate that there is almost a different objective. So in most stereotypical engineering research, we're looking to generalize the results, or generalize the results within, standard temperature and pressure sort of conditions. But when we're doing qualitative research, generalizability is not one of the objectives. We do have a responsibility to describe our context as well as we possibly can, so that a reader can transfer the findings to their situation. So it's more of an issue of transferability rather than generalizability. And understanding that difference, or that there is a difference, frees you up from questions around sample size, for example. That's typically a reviewer's comment. You only have 20 participants in this study. The sample size is too small. Now, if we were doing something statistical, that may very well be the case, but that's not the objective of qualitative research. Another challenge is understanding the importance of ethics and the ethics application process, not seeing it as an obstacle, but as a way to help you really design your research well.
Very, very important aspect of design. Thank you, Anne. Everyone put their reactions up for Anne. So thank you, Anne, for that presentation. And we'll quickly segue over to Jay Ashry now. Jay, if you'd like to share your screen with us, that would be great.
Yeah, thanks, Betsy. Just sharing my screen. Can you see my screen?
Here it is. Yes, we can.
Okay, thank you. Hi, everyone. So my talk is more on lifelong learning. As you know, lifelong learning, short courses, micro-credentials, these are the buzzwords of today, and they are getting a lot of popularity in the field of education. However, as academics, we know that this process is totally outside our regular curriculum, and we need to invest a lot of time in creating these short courses, in the midst of our other workload. So my talk today will focus on some of the strategies that I used in developing a short course in my disciplinary area last year. And that's what I'm trying to discuss here, to see how can we make use of our, given little time to develop these courses and what we gain out of these courses again. Okay, so now what is lifelong learning and why lifelong learning? Okay, so according to this OECD, which is the Organization for Economic Cooperation and Development, this is formed of 38 countries, including Australia. We see that 32% of the current jobs are likely to change, to see a significant change in the coming years. And we already know that the industry of today is very fast-paced, changing a lot. And what we are delivering for our students may get outdated by the time they graduate as well. So we need to also see, even for those professionals that are in the industry, their basic education gets outdated because there are a lot of changes that's happening in the industry, and the capabilities that they had developed in their current job may no longer be applicable with the new changing jobs as well. Therefore, lifelong learning becomes a key for everyone, not only for university graduates, but also for those in the job market to upskill themselves with the new skills. Okay, so the framework that we are going to talk about is mainly the partnership with the industry. So we know that the university, we develop strategic capabilities to develop our graduates. These capabilities basically to fill the knowledge gap in a particular discipline. And the industry, they have their own operational capabilities, which are actually company-specific training. But when these two are operating individually, we are not able to get that lifelong learning initiative. So when university and industry develop that partnership, then we can develop this lifelong learning, which actually gives the knowledge gap as well as the requirements of the industry that's taken up through this framework. Okay, so therefore the university industry partnership becomes important. However, when we develop the lifelong learning initiatives as academics, we cannot develop a short course just like that. We need to actually analyze the market requirements, what the industry really requires, and what are the things that our students require as well. And we should also probably try and find out what are the resources that we have and what are the other resources we can really outsource. For example, outsource in the sense taking some of the inputs from the industry as well. And of course, these have to be quality courses that are actually cost effective for anyone who can undertake these courses. And therefore, it's very important for us to work with the industry to develop these lifelong learning initiatives. Okay, so this table actually gives an idea of the role of the short courses. I don't want to just read this out, but as you can see here, the short courses are a popular choice for students and professionals to quickly gain the skills that they require. And these short courses also offer flexibility in time and the learning format as well, and enhances the professional skills for the industry professionals as well. And all of the short courses may not be micro-credentials in the sense that they are usually not credited, and they just complement the curriculum for graduates and for industry professionals. It gives them the specific skills in their current job, or if they want to switch from one job to another. So they need all these skills. So the short courses are becoming very important. So one of the strategies what I used is mainly, as we all know, very popular model, the students as partners approach. So many higher education institutions are using that. In fact, UNSW has been using it for a long time now. So the partnership with the students, basically, we use it for developing any co-designing or co-developing the curriculum, the materials, and we also have students involving in researching and finding out what are the skills required or whatever, inquiring. So with the students as partners, we adopt the 3 R's, which is the respect that we have on the students and the students have on us, the reciprocity, and the responsibility that we give the students. And by way of doing this, we develop their student skills as well. So this is the main pedagogy that I used when I decided to develop a short course. So I'll be showing here some of my students' faces, thereby also acknowledging them for their contribution. So what I have here is, this is my PhD student, who is actually a PhD student doing engineering education in the field of curriculum development, with a case study on specifically in my area, which is the power engineering curriculum. So the PhD student, as part of his PhD, he has already developed certain research objectives to find what is the gap between the industry requirements and what we offer in the university. With the fast changing industry, are we actually providing enough graduates who can have the skills, employability skills, to be directly employed in the job market, changing the job market? So as Anne pointed out, we have gone through a proper process of ethics approval as well. So we had everything in place. And the student actually started, as part of his research, started working on the existing job ads, looking at what is more required in this particular field, and also contacting the industry and interviewing them to find out what they expect in the graduates in our current field of renewable energy. Okay, so by way of doing this, I also had some thesis students interested in doing engineering education thesis. So therefore, I pulled the thesis student and then made the thesis student work with the existing PhD students. So thereby, they were able to share the work and do some additional work, so we could quickly get an outcome. So from these job ads and industry interviews, the outcome that came through was, PSCAD is a software that most of the power engineering industry, renewable industry are using at the moment. And universities are not actually using this PSCAD software and teaching them anything in that software, because most of the university, we stick to the standard MATLAB and other things. So universities are not actually equipping them. And this PSCAD software has now been rolled over into the industry so much that even the current industry professionals who have been working in this area are struggling because they have not used the PSCAD before. So we found a need that, okay, we need to use this PSCAD and develop something like grid integration studies. That's what we got from the job ads and the interview analysis, data analysis the student did. So what we did was, then we had to find out, go and approach an industry, because developing a curriculum, even for a short course, using that software on a particular aspect like grid integration studies is not that easy. We need to invest a lot of time. So the next step I did was, actually, I had a past PhD student who actually, after her PhD, went and worked with the company Orecon. So this is a consulting company again, who's primarily using this software for grid integration studies. And through this student, we just found out, okay, how much they are using this software in the industry for their analysis, and then pulled in an industry partner in the company, who's her boss, Derek was. And then we had a few meetings to find out, how important and whether the short course would help their professionals and whether they would be happy to be part of delivering the short course. And then this worked out very well. So then what we did is, we had to go on building the course plan, on developing the modules, how much our university should deliver, and what is our role and what is industry role, and stuff like that, whether we pull in students, industry professionals, and who are the ones who would be the participants of this course. And of course, including the course fee and the model and how long we need to do the course. So this again needs a lot of time and workload from our end. So coincidentally, we had the UNSW Digital Grid Futures Institute, which was actually calling for a seed funding to do some, this is basically, given that it's a Digital Grid Futures Institute, they were calling for research seed projects to work on some power engineering issues, power engineering problems of today. So we approached them and asked them whether they are happy to fund a development of a short course, which is again for the industry needs, and which we actually came out of this conclusion through our research, education research, and they were very happy to fund that. So we got a 20K fund. So then it became so easy for me to develop the materials and for developing the modules for the course. And again, I approached all my PhD students. I hope some of my PhD students are already in this talk here. So very happy to acknowledge them. And these are the students. So I had an engineering education student who was researching on this work, whereas I had two technical HDR students who are using the PSCAD software into their research. So it was very easy. They know how to use the PSCAD software. So we just made the students develop like lab manuals, so we can use it as a hands-on practice for the participants from our side. So all I used was use those students, and for these students, the time they actually had for developing the software, developing the modules for the software, all the funding came from the 20K funding that I received from the Digital Grid Futures Institute. So we had the modules ready. So then we had to actually, before going to this video, we had to actually try and find how many days we need to offer. So this is why PSCAD. Let's hear from the industry experts.
Look, PSCAD forms the cornerstone of the studies that we do. So it's really critical. It's really important for our work. And similarly, it's very important that the people that we employ and the people that we propose to employ have a very good understanding of the software and how it works. Look, having PSCAD knowledge is definitely an advantage. If that's certainly one of the first questions that we would ask in an interview. I wouldn't say it's a complete barrier to employment. We do not expect people to have significant advanced understanding of PSCAD when they join us, and we ourselves would spend a significant amount of time and effort into upskilling people, which is why the things that I mentioned earlier about the fundamental understanding of power system analysis and so on comes into play. If you've got the fundamentals behind you, then we can teach you the software. But certainly, if you have the understanding of the software, it makes you much more employable.
Okay, so this is what we had. The person here is Josias Visaji, who is from Oregon, who actually came as an industry expert to deliver the course as well. Okay, so this is, I don't want to, again, it's more technical probably for some. We had to develop the course outcomes. What are the outcomes of the course? Basically, we included all that is in practice. For example, the national electricity rules, the AEMO, who are actually the Australian energy market operator that manages the electricity and the gas markets across Australia. So we pulled out all the requirements and constructed a course that will be very practical and useful for not only graduates, but also the industry professionals. So what we did is, with this foundation, we offered a pilot version of the course last year in May. And we made it for 5 days with 2 days, first 2 days delivered by UNSW. So all we did was we developed like a lab-like content modules, and then we just delivered right from installing the PSCAD software and then running it with small models and stuff like that. And then the last 3 days, the industry came and ran some industry case studies with their bigger models, with the renewable energy models and other things. We had some 40 licenses for this software in our school, and therefore we thought, okay, we'll restrict to 35 participants in person to start with, so that, having a spare 5 licenses in case something goes wrong. And we had 32 enrollments, out of which 18 were UNSW students and 14 were from different industry in Australia. There were some from Melbourne, some from Brisbane as well. So they all came here and they spent the whole 1 week, 5 days, Monday to Friday with us. But we charged a very, very small amount of $300, which is not at all according to the market pricing. But we thought, okay, we wanted to see how this has been taken and whether it's useful for everyone. And because we had the funding, it was not a big problem. We just, gave also morning, afternoon tea and lunch for all the participants. For industry people, when they came, the feedback they gave was, this is an excellent course, but it's so cheap for us. Like our industry was very happy to sponsor us because all they had to do is mainly help us with the accommodation that they had to sponsor because the course fee was quite small. And marketing, we managed, like we tried to, through our industry contacts, we tried to publicize that and through LinkedIn and other things. All catering and logistics, we took the support from our schools. And as I said, ethics approval we had. And so we were able to run some surveys at the end of the course to gauge the interest and the feedback from the participants. So this was a first pilot we did. And so what happened was, as you can see, the learnings we had from the pilot, there was one UNSW student who was directly placed in Oregon because the industry person was there and he was able to see the participants directly, their engagement, their learnings. And one PhD student who was writing his thesis, he was directly placed immediately in Oregon after the course. So that was a fantastic success for us. And then what we did was, we did through our engineering education research, we did the data analysis based on the feedback and the survey that we took from the participants. And what we had was, we created a version 2 where the participants mentioned that the industry was very fast-paced, the industry instructions, because they are going into a bigger model and going into complete analysis. So therefore, they wanted more of a hands-on experience at the foundation, because as you saw in the first version, there were 18 students who are, like 3rd and 4th years of undergraduate degree. So for them, it was really hard. And even industry professionals said that they would like more of a hands-on. So we created a version 2 with 3 days from UNSW and 2 days from industry. So what we did, in the 3rd day, we had to develop the model that the industry is using, help the students understand that model as well. Therefore, I had to have more training for my own PhD students because that's an industry-based model. So what happened was, coincidentally, the PSCAT software is developed by this company called MHI. This is Manitoba Hydro Inc., which is a company in Canada. They are the ones who developed the PSCAT software. And coincidentally, they had come to Sydney last year to deliver a training program on PSCAT. So using the funding I had, I sponsored these 2 PhD students of mine to attend the training program with Manitoba Inc. And then that helped them to understand the wider and deeper ideas of modeling, bigger modeling in the renewable energy field. And not only that, because they went for the training, I was able to connect to the MD of Manitoba Inc., who was already available in Sydney. So I invited him to come to UNSW just to tell him that we have been running this course and we are looking for running this course every time. So they visited UNSW. And on visiting UNSW, on seeing this course model and everything, he actually offered directly 200 free educational licenses. So we got straight away. And in fact, these 200 free licenses at the moment, there's no limit of time. He said you can use it and then you use it for your courses and other things as well. And of course, it's very good for them because the more people use the software, it's good for them as well. But he was so generous to give us 200 free licenses. So because we had that, I ran a second version of the course again in September last year, where we offered a hybrid version. So we said, because we have 200 licenses, there's nothing to restrict us. So we offered both online and face-to-face for the participants, and we made it as a 3+2 model. So we needed more resources. So all my PhD students, there were some students totally dedicated to online participants. If they have doubts, we put them into a breakout room and then help them with understanding the software and other things. Okay, so the second version, which we ran in a week of term 3, we ran 3 days by UNSW and 2 days by industry. We had 11 in person and 13 online. And if you see the mix, we had only 6 students. There were 17 industry participants with 3 from overseas, like places like Canada, Dubai, whose timings are actually midnight when we are running the course, and they all joined the course. And so we also had one academic from University of Queensland who was so interested and wanted to learn so that they can implement the software into their course as well in their teaching. And we increased the course fee this time, obviously, because we know we did a market analysis and we saw there are some other universities offering similar courses using PSCAT, but not exactly. So we wanted to make sure that our course is very distinct. where we actually provided more hands-on, and then only one industry actually touching on many of the industry requirements. So we increased the fee. This range is because for students we always offered a higher discount, and for industry professionals we kept it at the full price. And then we only provided morning and afternoon tea. But then TGFI, because we had a funding from them, they were able to help us with more marketing because they had more connections with the power engineering industries, and again catering and logistics we organized from the school. So this was the second version where we had a mix. So then what we had is we wanted a more sustainable model to continue developing this course, because like my students, PhD students are not always going to be here. Once they finish the PhD, they have to move on. And I'm also probably getting into more and more other responsibilities and roles, and I can't be running this course every time. So we wanted to come out with a sustainable model so that we have a fixed pricing and we have something to do. And that's when we have this AGSE, which is the Australian Graduate School of Engineering. And we approached them and asked them, we told them we have all the models set and we have trialed the model. So if you could run the course, just give us, we give a block of time and we'll just run the course, but you manage the rest. And because it's the first time for AGSE, they said this year we ran in September again in a week. 2023. So they said we'll only take an in-person mode to see how this works, and then next year we can probably go for hybrid again. So we had 13 participants, but the course fee then increased to 3,000 with AJSC's model. We offered a 50% discount for UNSW students. Again, we had only 6 UNSW students because it was a bit costly for them, but we had 6 industry and 1 academic coming from University of Tasmania. So this actually went on very well. I think going forward, this will be a very sustainable model for us because AGSE will start running these courses, and I'm creating a pool of training for my other HDR students so that people can it's more like a lab demonstration. So AGSE pays the student directly for their time involved, and industry came, and if you can see here in the photo, this industry, Josias regularly involves with us, and then she's my past PhD students. She being in the industry, she came as a trainer as well. And it was a very proud moment to see our own PhD students coming and training future students and other professionals. So overall, if you see there we actually trained 65 plus engineers so far, and so many students got employment, and many engineers said that they were able to shift their roles from one industry to energy industry. Our HDR, all my HDR students who were involved in delivering this course, they either received paid internship, and some of the students received direct placement in Oregon. And in fact, one of my other HDR students who graduated early this year, she got direct placement with Manitoba Hydro as well. So this was very good. And apart from that, we published, because we have the ethics approval, and as part of research, we publish all our findings in this largest conference in the American Society of Engineering Education. And both the papers got the best paper, top 2 best paper awards as well. And of course, one thing is the course fee moved from 300 when we started the pilot to 3,000. It's not a big impact, but 3,000 is probably the market rate. But we started with a very small, and it was not long. We started, the first offering was in May, and then by September this year, we already reached the market rate and we are able to offer. And we have fantastic feedback from all the participants saying that it's a unique course because provides a hands-on, it takes you and because we have 200 license, one other advantage is we give them a online license for another 1 week after the course so that they can just practice and get used to, rather than just stopping at that point, and then we withdraw the license after 2 weeks. So that's very useful. That's the model we are using. So here are some reflections from the participants.
It's not only useful for postgraduate students or people who already have an industry background and to attend this course, but also for even undergraduate students who are have this aspiration to work in renewable industry. It would be a really useful course.
But still, like, it was really good getting insight into how these models are used in industry and what like scenarios and stuff they're used in. Also went through like what the simulation results meant, what the graphs meant, what you expect to see, and all of that. So that was all really good.
Learning how to drive PSCAD and having that hands-on experience and learning how to do it from the experts. I think that's probably the best, well, one of the best things, and the others are meeting new people, like, you know, staff from the university like yourself. So that's always a good thing.
So from this course, I know for the real industry, how did they do this part? And I think later I can introduce to my student.
So this is actually the academic. So everyone were very happy.
It's not...
So just concluding that the short courses are really good. They complement in this case, we have seen that they complement the existing power engineering program, provides, you know, industry networking opportunities as well. The course has benefited everyone, the students, the academics, and the industry professionals. Also, you know, like it keeps them, you know, it improves mainly the employability skills and then make everyone job ready. So the key here is the student as partner model and the industry partnership. They are the main keys for the success of this course. And I think if you adapt that model, I think this can be applied to any discipline. Once we have identified good students would be probably the only main thing. And then once we have identified good students and an industry partner, I think we can keep developing such short courses, which will be really useful for everyone. Okay, so thank you. I can take questions, and of course, my acknowledgement to all my students here in the photo and Oricon, the company. And of course, you should have a lot of resources to always, you know, like take your students for coffee and bites now and then to keep them engaged and network with them.
Fantastic. Thank you so much, Jayashri. Everyone put your emoji icons in the chat or just clap along. Fantastic. So there aren't any questions in the chat, but I will say something that's, you know, based on your presentation, Jayashri, great model. So you've talked about the gap filling between university and employability and industry. Could this be a new way of creating these so-called bridging courses? We have bridging courses when we enter the university. How about a bridging course when we exit the university?
Yes, definitely. Yeah, it's a great idea. We can do that as well, because we have certain things planned in our program, in our curriculum, and then adding an extra to that, and especially for us, given the 10-week turnover of the term, we can't actually add extra bits based on the industry requirements, even if we want to. So maybe those bridging courses like this would really help. And it's a great experience for our students, probably the graduating students, or need not be always HTR, even good graduating students, we can probably use them if they have done probably a thesis on a particular topic, and then we can use them to develop this course. And it's a great experience for those students as well.
Yeah, it's a real apprenticeship model of, you know, and students as partners, as you've described. So Jayashri, there aren't any questions in the chat, but I would encourage everyone to contact Jayashri. We can give out the email details for both you and Anne at the conclusion of this webinar, just so people know your work. This is recorded, so they can always catch up. I think we're done on this end in terms of the presentations. Now it's over to Alex as our PVCESE to wrap it up. Thank you, Alex.
Thanks, Patsy, and thanks, everybody. Really fantastic to hear two ends of the spectrum, really, about engineering education. So sort of Jayashri's intensely practical and useful and almost just-in-time education, and sort of broader, deeper theoretical sort of framing of why we're teaching. And I was particularly fascinated by sort of Anne's talk, because coming from a humanities end myself, it's that epistemological sort of the ground disappearing underneath you operates in reverse. So I think, you know, where engineers are used to objective and need to go into qualitative from the humanities, feelings aren't enough. You actually need some hard evidence. So moving into sort of more quantitative stuff is difficult. So I think one of the really fascinating things about this whole area is the way in which we all come out of our comfort zones and we all have to actually engage with other disciplines. And it's only when you do that that you actually discover the richness of what education, research and work can do, and feeding all the way back from that sort of broader theoretical thing, but back into exactly what Jayashri is doing. Those really practical forms of education work because of the way in which people have thought about how to teach and how to teach better, and how the theory. So there's a virtuous circle between both. You can't have theory without practice, and you can't have practice really good. Well, sorry, you can have practice without theory, but practice is better with theory. I think it's a better way to put it. So I'd just like to thank both the speakers for a really interesting and really thoughtful pair of presentations, which I think work so well as a duo. So